welcome back. So in this video we're going to move on to the let keyword in ECMAScript 6 and basically how that differs between it and the var keyword. Now before I get into let me just quickly explain a few things about the var keyword and variables in JavaScript. So to start off with, variables in ECMAScript 5 and down were basically scoped to either the global, which is the entire application, or it was scoped to a particular function. So for example, if I was to create a function here, like so, I forgot to give it a name, I'll just call it test scopes, like so. Alright. If I, inside of here, decide to have an if condition, we'll just go if true, because I'm lazy. And inside of here I go var local, we'll go var local scope, like so, is equal to 3. And go, okay, cool. Well, I can still access this outside of the if condition, even though this is declared inside of an if block, right? So in some languages you can't get away with this. So I can come out here and I can actually console.log out that var local scope. I can actually see it. Why? Because it's bound inside the boundary of this function. Okay, so if I quickly jump over and check this out, so I go load let versus var. Oh, yeah, see what happened there. Var local scope. Oh, sorry. Forgot to call test scopes. I need to do that, otherwise it's not going to invoke it. So try this again. And we can see the value 3 came out. Now, interestingly enough, as I said, the variable was declared inside of an if block, but then I was able to see it outside of that if block. And with variables, you can do this kind of stuff, right? Other things you can do with variables is I can actually redeclare the same variable twice. I can come in and make that 4, alright, for example. And it won't complain. So if I come in and I now jump over, you'll see the value just changes to 4, and it doesn't complain about them and say, oh, you've already defined this, or whatever. It just goes, okay, we'll accept your second result, and we'll assume that's what you meant. You wanted to have it set to 4. Now, with the let keyword that was brought into ECMAScript 6, a lot of this stuff doesn't work. So, for example, if I go inside this if condition, and I go, I'll even go outside of it to start with. So we'll create one at the top of the function called let local scope, and we'll set it to 1, right? Now if I console.log down here, let local scope, then this should still print out 1, right? Because it's within the same scope as where I've declared it. So come in, this is no different to a var at this point, right? Where it differs is when I put the same let variable name in here. So if I go let local scope inside of the if condition and say I set it to, we'll say 2, right? So based on the rules that we had before, this, if it was a var one, would have changed to a 2, so therefore this would print out a 2. But does it actually do that? The answer is no, it does not. It stays as a 1, right? And why? Because this let variable is actually scoped to this if condition. Once I leave this if condition, the value of let local scope, or whatever's perceived here, will now point back to one that's at the same block level, which is this one here, or outside of it. Alright? So for example, if I wanted to then say I want to use a global scope here and print it in here using the let command, you can still do this. So I can go let global scope, equals, we'll say 9. If I want to console.log out inside the if condition what global scope is, alright, I should put let global scope. So I remember that's a let. So this will print out a 9. Right, so it prints out the 9 and then the 4 and the 1, right? So it understands anything outside of its block. It's just that if it's defined with inside an inner block, it won't remember it anymore, right? So as I said, I declared a let local scope 2 here. I declared a let local scope 1 here. When I console.logged it outside the if condition, it was a 1. If I console.log it inside of here, let local scope, because I've defined it inside of this if condition, it will print out 2. So you'll see 9241. Right? So that's kind of one of the differences. The other difference is I can't actually define the same variable twice. So I can't go equals 7. In fact, Visual Code will actually tell me that it can't do this. I can still save it, I can still try and run it, and the node compiler will tell me it's already been declared. So that's one difference. You can't do that. So that's cool, alright? The other thing you can't do is you can't declare something that's inside this if condition and then try and access it outside of a block. So, for example, if I create an inner block in here and I declare a variable inside of here, so inner block scope equals 6, for example, I can log it in here. So I can go inner block scope, and that'll be all cool. It'll print out the 6. So if I jump over, I go node, you'll see the 6, right? However, because it was declared inside this block, if I now try and log it out here, because now it's outside that code block, and I hadn't defined the same variable at this level or higher, it's going to say, no, you're trying to access something that's basically deeper than where you currently are. So it won't let me. It's been scoped to here and not scoped to here, so it won't be accessible. So this will actually break. As you can see, it says it's not defined, but essentially it's not defined because once we leave this block scope here, this is basically destroyed and now set to undefined. So we can't do this either. Whereas with var, we can do all these things because we're inside the scope of a function. But with let, it works in a different way in which it lives for the scope of the block that it's currently contained in. That's the difference between the two. Now, you might say, oh, okay, that's all good and everything, but we've been using var for years and it's never been a major hiccup before. What benefits do we actually get out of using let? Well, firstly, you can't have situations like this where you accidentally declare the same thing twice. That's the first benefit. So you're actually making sure that you have one variable and one variable only for the purpose of the block, and that's it. So you don't have situations where things are modified inside of other blocks, and then when it comes outside that block, then it's been modified again, so on and so forth. But the real benefit is when you refer to closures and asynchronous callback calls. So just to show an example of what can go wrong with vars, and I don't know if anyone has seen this before, but just think of a loop. So if we go var I equals 0, I is less than 10, I plus plus, like so. And say inside of here we've got some asynchronous call that gets fired, right? So I'm going to use a set timeout to achieve this. So there's set timeout, and I'm going to go function, and so here I'm going to go console.log I, right? Now, if anyone's done enough JavaScript long enough, they'll know that this doesn't exactly work how you intend it to. Alright, so the idea is that when I comes in, it will call set timeout, it'll create a function, pass it, and then console.log I will be invoked, right? But because this is delayed, I changes over time, right? Because we're using var. I changes over time because I can be changed outside the scope of this function, right? And because it can be changed, that means that what we're logging out can be changed. And just to show you, if I jump over to the code here and run it, what you're going to see is you're going to see a whole bunch of 10s. And that is because before the first time this function is invoked, after a second, this I is already iterated through the loop and it's been changed to a maximum of 10, right? It's already hit 10 and gone, okay, we're now at 10, so when we call console.log for the first time, it's just left it at 10 for all of them. So in the old days, there was one way to fix this, and that was to wrap this call in a function and pass I in as a parameter. So it looks something like this. So this was the ECMAScript 5 way of, or down way of resolving it. You would do something like function, and we'd say index, right? And then because you have the index, then you can go set timeout and basically grab this thing here, right? And we'll change this to index. And then because you set a parameter here, you would immediately invoke it, passing an I. So then this I would be copied by value to this index, right? So at the time in which this was ready to execute, it would have the copied value of what I was at that point in time in the loop and would execute the log correctly, right? So that was kind of how you handled the closure problem with the var keyword and loops if you had an asynchronous call inside of a for loop. So just to demonstrate that this actually works, we jump over, I'll clear the screen again, and you'll see we now get 0, 1, 2, all the way through to 9, right? So now we're getting the right value for each iteration of the loop being logged out in that set timeout call. But this is where the power of the let command really helps us. If I decide to just comment all this out for a moment, and just underneath it, I'm going to go something very similar. I'm going to use let this time. Let I equals 0, I is less than 10, I plus plus, right? And I'm going to copy the first example I had here. Now the difference is, instead of var, I'm using let. What do you expect is going to happen here? Let's find out. So we get the numbers, and then, well, wait a minute, we're still getting 0 through to 9, so the values are being passed properly. Now, why is this the case? Well, as I said, whenever we use the let option instead of the var option, this is scoped to the body that it currently is sitting in. So it'll execute this command, and I will be whatever the value is for that block at that point in time. Then when it iterates through a second time, it's a new block with a new value. So the first iteration it goes through, it creates a new block with I being set to 0, so it's always 0. Gets to the end of the block, comes back to the loop, I is changed and passed through again. Now it's set to 1. It's only 1 for the lifetime of that iteration. So that's 1. Then it loops through again. The number gets changed to 2. It loops for the lifetime of that iteration. Then 3, lifetime of that iteration. And so that allows this I to be consistent for each loop, no matter whether we're using a synchronous call or an asynchronous one. So basically that's the let variable, let keyword, as opposed to the var one. In the next video, I'm going to quickly just talk about the const keyword and how that compares to the let keyword. So I'll see you in the next video.